Now, when we were looking at the previous example, we found expressions where we had to add pi n, where n was any integer, and it didn't matter what it was. But now we have a restriction on our domain, and we notice that there's a restriction on our domain because it says right here where x belongs to 0 to 4 inclusive. That means that the absolute minimum value that x can be is 0, and that the absolute maximum value that x can be is 4. And it means that we have to work within those constraints as well. So we're going to start by solving the equation and keeping it very general, and then we're going to make it more specific to the actual solution that's being asked of us. So what we'll do is we'll start by isolating the function itself again. And this time we're working with a cosine function. So we're going to try to isolate the cosine function as much as possible. And the first thing we'll notice is that we have a root 2 that's multiplying the cosine function. And so what we'll have to write here is that we're going to divide both sides by the square root of 2. And so we'll end up with cos of pi times x plus 1/4 is equal to 1 over the square root of 2. Okay, now if we start looking for values of angles that give us 1 over square root 2 on our unit circle, we might not find it because it's given to us in a different way of representation. So if we start by rationalizing the denominator for this particular function here, and to do that we'll have to multiply by the square root of 2 over the square root of 2 to get rid of the root 2 in the bottom. What we'll find is that we end up dealing with the cosine of pi over x plus 1/4 is equal to the square root of 2 over 2. And now this you can easily find on your unit circle. And you'll notice that the cosine, or sorry, the angle value when the cos is root 2 over 2 is at pi over 4. Okay, so we end up with two equations. We have the cosine, oh, sorry, not the cosine. We will end up with pi times x plus 1/4 is equal to pi over 4. And the other value where the cosine is root 2 over 2 is for pi times x plus 1/4 is equal to 7 pi over 4. And again, we have to count for the multiple rotations of our unit circle, and so we'll have to add plus 2 pi n plus 2 pi n. Okay, and we're going to start by reducing it down to x as much as possible, just like we did before, to try to isolate it. And when we do this, we'll divide both sides by pi, and so we'll have x plus 1/4 is equal to 1/4 plus 2n. And then we'll add, or sorry, we'll subtract 1/4 from both sides. So here we will have that x is equal to 0 plus 2n. So effectively leaving us just with 2n. And we'll do the same thing for the other equation. And we'll find that x plus 1/4 is equal to 7 over 4 plus 2n. And when we subtract 1/4 from both sides, we find that x is equal to 6 over 4, which is the same thing as 3 over 2 plus 2n. Okay, now these are giving us all of the solutions, all of the possible solutions for the values of x. But we have to keep in mind that our values are restricted between 0 and 4. So when we use a value of 0 for our n, so if we let n be equal to 0, that means that our first x value is going to be 0 plus 2 times 0, which is just 0. And that falls within our range between 0 and 4. Our second value, still keeping n as 0, is going to give us 3 over 2 plus 2 times 0, which is equal to 3 over 2. And this is still within the range of 0 to 4. Now we're going to let n be equal to 1. And so our third possible x is going to come from doing 0 plus 2 times 1, which is equal to 2. And this still falls within the range of 0 to 4, and so we're okay. And then we'll try our fourth x value. This will be 3 over 2 plus 2 times 1, which is going to give us 7 over 2. And so this still falls within the range of 0 to 4, because 7 over 2 is 3.5. And so it's still valid. And now when we move on to another n value, so if we let n be equal to 2, our next highest x value is going to be 0 plus 2 times 2, which is equal to 4. So again, this is still valid, and so we can accept it. But when we move on to the one coming from the second equation, we will do 3 over 2 plus 2 times 2, which is 3 over 2 plus 4, which is equal to 11 over 2. Now 11 over 2 is 5.5, and 5.5 falls outside the range of 0 to 4, and so it's not acceptable as a solution. So the only values that are giving us acceptable values as a solution are the following. We have this one here because it's 0, we have this one here because it's 3 over 2, this one here because it is 2, this one here because it is 7 over 2, and this one here because it is 4. This other one here is not acceptable because it falls outside of the range of 0 to 4. And so when we have to write our answers, we're going to write that our acceptable answers for x are, and we're going to use the curly brackets to denote a set. We're going to say 0, 3 over 2, 2, 7 over 2, and 4. And these are the only acceptable values for x that solve this equation and still fall within the range of 0 to 4.